Hello everyone. I welcome you in the next lecture of 12th class NCERT Mathematics. In this video lecture we will discuss question number 22 and question number 23 of exercise 5.1. Similar to all the 21 questions which we already discussed of exercise 5.1, in this question 22 and 23 we will discuss the continuity of the given functions. So here without further ado, let's get started. Question number 22 and question number 23. So discuss the continuity of the cosine, cosecant, secant and cotangent function. In this complete question number 22, we will apply algebra of continuity. Okay, so here first part we have function is cosine is there, that is cos of x. Okay, so for this one we need to prove in general, but for cosecant, secant and cotangent we will prove by the algebra of continuity. Okay, so cosine, cosec, how we can prove? You can choose let a belongs to R, any real number we can choose. Okay, and for that real number we need to find the LHL, RHL and f of a, because if all these three things LHL, RHL and f of a are equal, then we can say the function is continuous. So first of all we need to find LHL. Limit x tends to a negative f of x, limit h tends to 0 f of a minus h, limit h tends to 0 cos of a minus h, and here limit h tends to 0 cos a cos h plus sin a sin h. If you apply limit, what we will get here? This is your cos a plus 0. So here cos a will get. Okay, this is your LHL. Here we will find f of a. What is f of a? Is cos of a again. Okay, assume it is first equation, assume it is second equation. Now we need to find RHL of for this one. RHL equal to the limit x tends to a positive f of x, limit h tends to 0 f of a plus h we have, and here again limit h tends to 0 f of a plus h we will find by this star equation. So we have cos of a plus h. Again we need to open the formula of cos of a plus b. What we have? Limit h tends to 0 cos a cos h minus sin a sin h. Okay, if you apply limit here, what we will get? We will get here cos a only again. So this is your RHL equation number 2. So we can conclude that from equation first, second, this is your third equation. From equation first, second and third we have LHL equal to RHL equal to f of a, implies that f is continuous at a. Here you can see that this function is continuous at a, and what a took, a is an arbitrary real number. If a is an arbitrary real number and for that f is a continuous at a, we can imply that it is true for all a. So in general what we need to write, since a is arbitrary real number, implies f is continuous on R. I hope you understand this complete question. Okay, the first part, that is cos x continuity. So it is continuous for all x belongs to R. Obviously by the graph also we can observe that, see, like that we can draw the graph of cos x. So without lifting our pen we can draw the graph. It is also here also it is. Okay, it is like that. So Without lifting our pen, we can draw the graph of the cosec throughout the complete R. Hence, the function is continuous on R. By the graph also we can observe, but we need to prove it in general. Okay. Now cosecant. Cosecant is f of x is cosecant. That means cosec of x. It means 1 upon sine of x. Here we can use the algebra of continuity of the sin x. What it will be? F is continuous. What we need to write? We need to write that as sin x is continuous for all x belongs to R. Okay, as sin x is continuous for all x belongs to R, here fx equal to the 1 upon sine of x. What we have? 1 upon sine of x. But the domain of this function, domain of f is R minus n pi, where n belongs to the z we have. Okay, because we already know the graph of the sin x. Here you can observe the graph of the sin x is, it is like that. Okay, it is like that, graph of sin of x. So here at this point, at this point, at this point, at this point, all these points are 0, pi, 0, pi, 2 pi, 3 pi, up to so on. We have here minus pi, here minus 2 pi, so up to so on we have like that. Okay, so at all these n pi, the sign is 0, hence 1 upon sine is not defined, obviously, because 1 upon 0 will come and 1 upon 0 it will not define. So we need to remove from the R, and hence this is this collection of all the elements on which f is defined, and hence it is the largest subset of R on which f is defined, hence it is called the domain of the function f, that is 1 upon sine x. Okay, now the continuity of the function, clearly using algebra, of continuity of the function, clearly using algebra of the continuity of the function, we can conclude f of x is continuous on df. Okay, f is continuous on df. It means that where it is discontinuous, it is discontinuous at n pi. At n pi it is discontinuous. Now same as that, secant is 1 upon cos. So the secant one is your homework. You need to complete the secant one. Okay, secant you need to complete. Why you need to complete? Because 1 upon cos is there, and cos x we already know that where it is 0, at 2 n plus 1 pi by 2. Where it is 0? At 2 n plus 1 pi by 2. Wait, I'll do one more. Okay, yeah, this one is enough. Yeah, this is the C part. What is our C part? F of x equal to the secant of x is there. The meaning is 1 upon cos x is there. So the domain of this function is clearly R minus 2n plus 1 pi by 2 is there, where n is belong to the z. Okay, so why so this thing is there? Because you can observe that the graph of the cos x is like that. Okay, and this is minus pi by 2, this is pi by 2, then it is 3 pi by 2, up to so on we have. Okay, So at pi by 2 minus pi by 2 it is 0. So we need to remove all those elements on which cos x is 0 to define sec x. Okay. Clearly again by algebra of continuity we can conclude that this function is continuous on df by the algebra of continuity, because cos x we already proved that it is continuous. So we need to remove just only those points on which it is 0. Okay. Because it is in rational format, it is in px upon qx format. Okay. It is a type of quotient function like px upon qx format. So where qx is 0 we need to remove all those points. If px and qx both are continuous and qx where at how many points it is 0, we need to just remove all those points from the set of real number, and hence we can say that the function is continuous at all those points on which qx is non-zero. Okay. D1 is function f of x you have and quote of x you have. Okay. So what is the meaning of quote of x? It is cos x upon sin x. Again it is same as that our b part. Same as that b part. Why so? Again domain of this function is complete r minus and pi and belong to z we have. Okay. So what they are saying that again using algebra of continuity of function as cos x and sin x continuous for all x belongs to R, and so for all x belongs to df, f is continuous on df. Why so? Because you already know that we need to remove all those points on which f is not defined. Okay, for the continuity of the function. I hope you understand this question. Move on to the next question. So here they are saying that find all the points of discontinuity of f where f of x equal to this sin x upon x. This we have. Okay. So actually this question has three parts. The first part is A, I assume. The second part is B, we'll discuss, and the third part is C. Okay. So the first part is before 0, after 0 and equal to 0. Domain of this function is complete R, 0. Here we have here, and at 0 we need to check. Okay. So before 0 we can check and after 0 we can check. Observe that. Before 0 the function is, what do we need to write? For all x belongs to R negative. Okay. F of x value is what we have? Sin x upon x. Again we need to use algebra of function of continuity. What we need to write? That function fx is written as sin x upon x. One is, here two functions are using, gx is sin x and h of x is x. These two functions are using. Sin x and x both are continuous functions, because sin x is a trigonometric function and h of x is a polynomial function, so they both are continuous for all x belongs to R negative. Hence their algebra, that is sin x upon x, is also continuous for all x belongs to R negative, because the domain of this function here it is defined on R negative, so it is nowhere, this denominator is nowhere 0. That's why this function is continuous throughout the R negative. I hope you understand what I said here. The B part is for all x belongs to R positive. So again f of x is here x plus 1. So here we can say this function is polynomial function and it is continuous throughout the R, hence it is continuous on R positive also, therefore this function is also continuous. It implies that this complete function is continuous on R positive union R negative. Now we need to check where the at 0, at x equal to 0 we need to check this continuity. For that we need to find LHL. What is LHL? Limit x tends to 0 negative f of x, limit h tends to 0 f of 0 minus h. 0 minus h we will find by the this one branch, first branch, okay, first piece, limit h tends to 0, sine of minus h, minus of h, sine of minus theta is minus sine theta, so limit h tends to 0, sine h upon h, it implies 1, okay. Now what about RHL? RHL is limit x tends to 0 positive f of x, limit h tends to 0 f of 0 plus h, and limit this value we can find by the second piece, that is h plus, wait, h plus 1, and if you apply limit we will get 1, okay. And f of 0 is, what is f of 0? F of 0 value is 1, so it implies that LHL equal to RHL equal to f of 0. It implies that f is continuous at x equal to 0. I hope you understand what I said, that before first three part we complete this question. The first part, before 0 function continuous, algebra we can use. After 0 we can use algebra, simply not algebra, simply the polynomial continuity. And on C we need to check left side, right side, and f of 0. Okay, I hope you understand this question. Okay, if you have any doubt then you can do comments, I will rectify your query there. Thank you for watching.